Hey everyone, ready to dive into something pretty cool.
Always up for a challenge.
Today it's functional programming.
Yeah.
It's kind of like instead of your code being a messy to-do list, it's more like elegant math, you know,
I like the sound of that already.
right. And to guide us, we've got excerpts from Bird and Wadler's Introduction to Functional Programming. This book's practically famous, even though it's from way back.
Late 80s, right? A classic for sure.
Exactly. So should we just jump right in?
Let's do it.
Okay, so they start with this idea, referential transparency. I gotta admit, sounds a bit intimidating at first.
It's simpler than it sounds, actually. Imagine you've got some code, right? In a referentially transparent world, that code, its meaning is its value, nothing else. No matter where it is, always the same outcome.
So kind of like if I'm making a cake, doesn't matter if I measure the flour first or last, as long as it gets in there, the cake should be the same.
Exactly. Bird and Wadler, they use this example, square, 3, 4. You could do 3, 4 first, get 7, then square it, 49, right? Or square directly, 3, 4, x, 3, 4. Still 49. Different ways to calculate, same result.
Because in their world, 3, 4, and 7, they're basically the same thing.
Spot on. Makes code more reliable, way easier to debug. No surprises, everything acts how you'd expect.
Like a trustworthy map, no matter which path you take, you get where you need to go.
Okay.
So that's referential transparency. Now, they also talk about types, which seems pretty standard in programming, what makes it special in functional programming.
You're right, types are everywhere. But here they're like fundamental. They're how we organize data, like categories. You've got num for numbers, bool for true or false.
Like sorting ingredients before cooking keeps things organized.
Exactly, but it gets cooler. You can build complex types from simple ones, like with Lego, pairs of numbers and letters, or even lists inside lists.
Whoa, so you start simple, then create something super complex.
Precisely. That's the beauty of it.
This is already making my brain do backflips.
Yeah.
And we haven't even gotten to functions themselves. Speaking of Bird and Wadler, they say functions are first-class citizens. What's that even mean?
Huh. It means functions, they're like the VIPs of this world. Just as important as data, like numbers or text.
So I can, like, put functions into variables,
Yeah.
like I would with a number.
Exactly. You can store them, pass them around, even have a function give you back another function. Super flexible.
Okay, now that's just cool. Any examples from the book come to mind?
Absolutely. Let's talk currying. Say you've got add, takes two numbers, adds them. Normally it's like add 3, 4, right?
Yeah, makes sense to me. What's different here?
With currying, add takes one number at a time. So it's add 3, 4. And get this, add 3 itself becomes a new function, one that's ready to add 3 to whatever comes next.
Whoa, so it's like add 3 is just chilling, waiting for that second number to do its thing. Functions inside functions, like those nesting dolls.
Perfect analogy. And this is key to how elegant functional programming can be.
We've covered referential transparency, types even currying. I feel like my brain needs a break. And I have a feeling this is just the beginning.
Oh, we're just getting started. But before we get ahead of ourselves, let's dig into how functional programming handles different data types, not just numbers.
Sounds like a plan. Lead the way. All right, so we're back and ready to tackle more of this functional programming world. And up next, we've got lists. But I have a feeling these aren't the grocery list kind, huh?
You got that right. In this world, lists are like the rock stars of data structures.
Rock stars, huh? I like it.
And you know what else? The way we work with them, it's all tied up with this idea of recursion. Remember that?
Recursion.
Yeah.
Okay, yeah. It's like those Russian nesting dolls, right?
Yeah.
Smaller dolls inside bigger ones.
Yeah.
Is that connection for real here?
It totally is. Recursion, it means defining things using themselves, right? And with lists, well, you can have lists inside lists, creating those nested structures just like the dolls.
So instead of just numbers or letters, a list can have like a whole other list tucked inside. That's kind of wild.
Precisely. It's like a superpower for organizing data. And the cool part is, recursion lets us write these really elegant bits of code to deal with all that nesting.
Okay, I'm seeing the appeal, but I need an example. How does recursion actually work with lists using Bird and Wadler's infinite wisdom, of course?
Let's take the functions head and tail. Head, it gives you the first element of a list, like the top item on your to-do list.
So just if my list is 1, 2, 3, 4, then head would be 1.
Exactly. And tail, well, that gives you everything but T, the first element. So 2, 3, 4 in that case.
Makes sense so far.
Now, here's the recursion magic. The definition of tail for a list that's not empty, it's actually just the tail of its own tail.
Whoa, wait a minute.
So the tail of 1, 2, 3, 4 is really just the same as the tail of 2, 3, 4. It's like peeling back layers, but with code.
Okay, I think I'm following. It's a chain reaction of tails until you hit the end.
You got it. And this elegant little definition, it handles any list, empty or not.
Pretty slick. I can see how this could apply to all sorts of list things. But isn't recursion, like, not always the most efficient? Doesn't it lead to a ton of function calls, especially with super long lists?
That's a great point. And you're right, efficiency is definitely something to consider. In fact, Bird and Wadler, they talk about it later in the book. We'll get there.
Okay, good to know.
But the takeaway for now is how elegantly recursion lets us express those complex list operations all neat and tidy.
All right, elegance has its own merits, for sure. But moving on, what about this pattern matching on lists that Bird and Wadler talk about? Sounds kind of like detective work, but with code.
Well, you're not far off with that detective comparison. It's like giving your code a set of instructions based on what the data looks like. If you see this structure, do this, but if you see that structure, do something else.
So instead of just checking if list is empty or not, I can actually write code that says, like, if it starts with this and then has that, and so on.
You got it. It's about recognizing patterns, not just asking yes/no questions. Your code becomes way smarter about how it handles things.
That is slick. Instead of rigid instructions, it's more like teaching the code to read the situation. That's got to be helpful.
Extremely. Makes things way more readable and concise. Honestly, just more enjoyable to work with.
Okay, pattern matching. Definitely adding that to my functional programming toolkit. But let's up the ante even more. Bird and Wadler introduce higher order functions. And honestly, that just sounds kind of intimidating now.
Don't worry, they're not as scary as they sound. It just means functions that can take other functions as arguments or even give you back a function as a result.
Hold on, functions working on other functions. That's like next level stuff.
It is. It's this whole other level of flexibility and expressiveness that you can tap into.
Okay, I'll bite. Give me some examples. What kind of higher order shenanigans do Bird and Wadler have up their sleeves?
Well, they start with map and filter, which you might have seen in other programming languages.
Oh yeah, map is like taking a function and running it on every single thing in a list, right? Mass
Yeah.
applying it, basically. And filter is like picking out only the things that fit a certain rule.
Perfect. Classic higher order functions. Map takes a function, takes a list, and boom, applies that function to each element. Filter is like your picky friend, only keeping what it likes.
So if map is the party animal, filter is the bouncer at the door.
Haha, exactly. But Bird and Wadler, they don't stop there. They introduce us to the fold.
Fold, as in folding a piece of paper. Now you're just messing with me.
I'm serious. Imagine you've got this long sheet of paper. The way you fold it, it determines the final shape, right? Fold functions do that with lists.
So they kind of like fold up the list by using a function over and over, depending on what you want to do.
Exactly. And just like paper, you can fold a list in different directions. There's fold left and fold right.
Okay, I'm kind of seeing it, but concrete example, please.
Sure. Let's say you want to add up all the numbers in a list, or maybe multiply them all together. You can do both using this folding idea.
Wait, really? So the function would be for adding and for multiplying.
You got it. Fold just applies that function step by step through the list. Same pattern, different outcome.
That's amazing. So with just fold, you can do all sorts of calculations on lists.
You see, elegant and powerful.
All right, fold, you have my attention. So we've got recursion, pattern matching, even dipped our toes into the higher order pool with map, filter, and fold. There's a lot of list action. And I bet there's still more, isn't there?
You're catching on quickly. We've covered a lot, but there's always more to learn. Before we get too far ahead, though, there's one more thing I want to touch on. Efficiency.
Ah, yes, of course. Because at the end of the day, elegant code is great, but if it takes forever to run, what good is it?
Exactly. And that's where Bird and Wadler, they really shine.
And we're back, ready to wrap up this functional programming journey with Bird and Wadler as our trusty guides.
Always up for more. We've covered a lot of ground, but efficiency, that's where it all comes together, right?
Absolutely. Elegant code is great, but it's got to perform in the real world too.
Exactly. And Bird and Wadler, they're not just about theory. They get into the nitty-gritty of making those programs sing.
Okay, I'm intrigued. Making them sing. What's their secret sauce?
Well, there's this concept they introduced called lazy evaluation. Might sound a bit, well, lazy, but trust me, it's genius.
Lazy evaluation. So the code just chills out until it absolutely has to do something. That's wild.
Pretty much. It's all about putting things off in a good way. Only when you need the answer does it actually do the calculation.
So like if I have a huge list, but I only need the first few things, I don't waste time figuring out the rest.
Exactly. They've got all these examples showing how lazy evaluation turns slow code lightning fast.
Okay, I'm sold. Lazy evaluation sounds like a superpower. Well, what else do they say about efficiency?
Well, they dig even deeper into how functional programs actually work, under the hood.
Hmm.
We talk about graph reduction. It's using like diagrams to represent the program.
Graphs, like with nodes and edges and all that, sounds kind of visual for coding.
It is. And the cool part is, this way, programs can run more efficiently. They can even run on multiple processors at the same time.
Whoa, hold up. At the same time, like multitasking on another level.
Exactly. And nowadays, with all these powerful computers, that's a big deal.
Makes sense. Bird and Wadler, they were ahead of their time.
For sure, their insights are timeless. And they don't even stop there. They talk about this mind-blowing thing called program synthesis.
Program synthesis. Okay, now I'm really lost.
It's basically like using special techniques to have the computer write the program for you based on what you want it to do.
Wait, hold the phone. The computer writes the program. That's some next level stuff.
It's still a bit futuristic, but Bird and Wadler, they give you a glimpse of the possibilities.
That's incredible. So instead of us slaving away, we just tell the computer what we want and poof, it figures it out.
That's the dream, right? And while it's not quite there yet, program synthesis, it has the potential to make programming easier, less buggy, and way more efficient.
Bird and Wadler, they really take us on a wild ride.
From the basics all the way to the future of coding.
They do, and through it all, they show us just how beautiful, how elegant, how powerful functional programming can be.
So for all our listeners out there, why should they care about functional programming?
It's all about writing better code. Code that's easier to understand, less likely to break, and often faster, too. It makes you think differently, solve problems in a whole new way.
And even though it might seem intimidating, Bird and Waller's book, it gives you this crystal clear way to dive right in. It's a must-read for any programmer who really wants to up their game, honestly.
So that wraps up our deep dive into the world of functional programming. Big thanks to Bird and Wadler for being our guides.
And to everyone listening, until next time, keep exploring, keep learning, and keep your code elegant.
And functional. See y'all next time.